E-Tech scooters. A company manufactures 4 different models of electric scooters that are powered by small electric motors. E-Tech Scooters has 2 facilities in Ohio. The first is their founding facility in Marietta, Ohio, which is the smaller of the 2. The second is located in Nelsonville, Ohio. The company has grown tremendously and ships all over the United States. Transportation costs can be ignored for the following problem. Develop a model to determine the optimal number of units of each of the 4 electric scooters to be produced at each facility, aiming to maximize annual profit. Hints: add a constraint to limit the solution to integers. The objective is going to be total revenue minus Marietta production costs minus Nelsonville production costs. And then we'll seed all the decision variables with 2, so let's do that right now. So these are the models of scooters: City Go, County Go, Highway Go, Interstate Go. And this is where they're being produced, either in Marietta or Nelsonville. So first let's get the total produced between the 2 plants. And then that's got to be greater than the minimum, or like that. And so these are kind of our goalposts. We have to be between 4 and 500. And so on, with the given mins and maxes of the scooter models that can be produced in total between the 2 plants. All right, now let's look at plants individually. So this is how much is on hand of the different parts that go into the scooters at the different plants. And so how much will actually be used in Marietta? It's going to be some product. And that's going to be just what happened in Marietta, which is this number. We're going to log times the parts to make those scooters appear. And then similarly, here, some product, Nelsonville, lock that, times this line, copy it down. It's going to be less than the maximum number of parts available for each of those types of parts in Nelsonville. Right? I mean, if you don't have the parts, you can't make the product. And then our total revenue is going to be equal to some product. And this time it's going to be total produced between the 2 plants times the wholesale price. And then for Marietta production costs, that will be some product, just Marietta, times production cost per unit Marietta, and similarly some product, just Nelsonville, times Nelsonville production cost per unit. And then finally, our total profit is going to be total revenue minus Marietta production costs minus Nelsonville production costs. Okay, that's a lot. And now let's do the solver piece. Okay, got lots of stuff going on here. So our variable cells, it is going to be a max. Our variable cells are going to be these. That's what solver is going to manipulate. And then we're going to start adding constraints. So let's put the constraint thing here. So the cell reference is going to be, start with these. We'll work with these goalpost constraints. So that's going to be greater than the minimums. Remember, even though the sign sort of looks like it's going this way, we're reversing it in the constraint because we're looking from the point of view of the middle, looking down towards the minimum. So we got to be greater than the minimum. And then we'll, again, looking from the middle, that one actually is less than the maximums. And then we'll add the constraint that these here are less than how much is available for Marietta. Same for Nelsonville. The amount that we're going to use of each type of part has to be less than the number of parts that Nelsonville actually has for each of those parts. What else would be a constraint? Let's see what we've got so far. So let me just click OK. Oops. Cancel this. All right. So we've got those constraints. And then let's add the constraint about the integer. So all of these need to be integers. All right, and then we'll pick simplex options, and remember it's check, uncheck, uncheck, 0, and then 10. And now we'll see if we got it. Solve. Objective cell contents must be a formula, so I knew I forgot something. So I'm going to have to close this. And this has to be a sum product too. Not a sum product, sorry. This is going to simply be equals revenue minus Marietta cost minus Nelsonville cost. All right, now let's try running solver. Oh, somehow it thinks I messed up. And now it's unhappy with me. I do have a formula there. I think this is my objective cell, isn't it? B47, let's try again. If not, okay, it's pointing to the wrong cell. Must have, or B47. Now let's try solve. Solver found an integer solution, Rubin tolerance, all constraints are satisfied, and as you can see here, we're all green, so that is wonderful. So our total profit is going to be 8,628,300 if we produce this many units at each plant. And you'll notice what's kind of interesting about this is some of these actually go to zeros because that will lead to the optimum maximization of profit. Okay. And now let's go ahead and name the ranges so that we can do our documentation. So in terms of formulas, go here. Create from selection. from selection. Great. That's going to be total produced max. Marietta used. Marietta available. Nelsonville used. Nelsonville available. And then create from selection. And then finally we've got to do these and we can highlight those, and this one, remember, we have to name by hand, so we'll say all units produced, and I'm actually going to make sure it doesn't get confused with the other all units produced. I'll call it all scooters. Scooters produced. No spaces. Hit enter. All right, and let's see if Solver picked up all those names. Great. So our objective, total profit, objective max. So that's going to be a maximum by changing variable cells. All scooters produced. All scooters produced have to be integers. Marietta used must be less than Marietta available. Nelsonville used less than Nelsonville available. Total produced needs to be less than. Total produced max. Total produced needs to be greater than the total produced minimum. So that all looks good. Let's do a screenshot. And paste that down here. No, maybe I have to close it first. There we go. And then let's get the names. So we'll go to formula, using formula. Okay, now this is going to be a bit of a mess because it's going to kind of mix things up. But we can fix that because I can click in here and treat this as a table as long as I paste it right under those headings. I can go to the Data tab, pick Sort. My list has headers, and pick the Refers To column, which will go A to Z, so eTech comes to the top since that's the one that we're on. And then click OK. Actually, that went to the bottom. But anyway, here's our. Here we go with the eTech scooters and all the ranges that have been identified next to each other, and then where all those ranges are used over here. So we have our complete documentation, and we're good to go.